few weeks ago, my television crashed. It just completely froze up. And the only thing I could do was to physically unplug it and plug it back into the wall. And in that moment of frustration, I shook my fist at the sky and said, why are televisions like that these days? TVs never used to crash. They used to be completely reliable. But in fairness, they also used to just show half a dozen channels and expect you to show up when they were ready to broadcast. Yeah, old televisions were rubbish. We're far better off in this modern world where you can watch whatever you want, whenever you want it, because your TV is now basically a computer. Even though they're less reliable because your TV is now basically a computer. Computers bring possibilities and problems. We know this. And it's the problems we're going to look at this week. Because how do you test television software? I mean, if you thought making things work across different browsers or across different smartphones got complicated, imagine testing across a field of 50-inch plasma TVs. The solution to that problem is actually one of the most interesting practical engineering stories I've heard in a long time. This week, I'm joined by Dave Lucia, and he works on a television software testing fleet that needs real-time video processing, Gen AI, WebRTC, some Lua scripting, and a large, fault-tolerant distributed Erlang system for scheduling, and a few more things besides. Sometimes solving a problem needs one big idea. This is the story of many interesting interlocking pieces that fit together, all in the hope that in future, my television won't crash. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Dave Lucia. Joining me today is Dave Lucia. Dave, how are you?
I'm doing great. Thank you for having me on, Chris.
Oh, pleasure. You're just off the back of organizing an Erlang conference, is that right?
That's right. Not just Erlang, but Erlang Elixir in Gleam. It was called Codebeam Lite NYC. We had it in Brooklyn, New York this past Friday, and it was wonderful. It was 10 talks, half hour each. We had the creator of Sonic Pi, Sam Aaron, on to give our keynote, and it was really a wonderful day.
That sounds really cool. I'm looking for an excuse to get to New York sometime. So next year, if you need to give someone a press pass, you let me know.
But this is wonderful marketing because now we're going to have to have you on next December.
I look forward to it. Okay, enough me pitching for free conference passes. I actually heard about you because I was looking at a similar conference over in Berlin, and you were talking about Lua on Erlang. And I thought, well, how did you get into that? And it turns out the answer is absolutely fascinating, through television software. Tell me the story of how you got into TV software development.
Wow. Okay. Well, it's a little bit of a convoluted path, and it involves, I guess, a decade of building relationships in the technology world. But I started out my career at Bloomberg, and Bloomberg is a financial services company. You might be familiar with the Bloomberg Terminal or maybe Bloomberg News. I started out on the Bloomberg Terminal building trading software. And about halfway through my 5-year stint at Bloomberg, I moved over to Bloomberg.com. And back in 2014, we rebuilt Bloomberg Business Week and Bloomberg Politics. And it was just a really fun time. This was like kind of right when React was starting to get popular. Okay, we built an open source framework that no one else used called Bloomberg Brisket, which was one of the first single page app frameworks in JavaScript. Sorry, this is convoluted, but I promise we'll get there.
I believe.
I met someone by the name of Stephen Baldwin who was consulting for Bloomberg, and we stayed friends throughout the years. I had since left Bloomberg to do a bunch of media startups. I worked in sports betting for a while. And after my most recent startup, I was looking to do something new and reconnected with my friend Stephen. And in the 8 odd years that we had not been working together, he had started working at his consultancy with a number of different media companies who built smart TV apps. And while they were building these smart TV apps, the pandemic hit, and they were having this challenge with their clients of, I'm building an app, I need to test it on an LG television. Sometimes the simulators are not so good, and so we need to make adjustments based on how it works on the physical hardware. And so what they started doing is they were taking their office space and they were sticking, a bunch of TVs in it, building a literal TV lab. And, they would have someone go in, they point a webcam at it, and someone would go in, sideload a build onto the TV and go ahead and test it. And after a certain point in time, they're running into all these challenges with making this work and realize, this could really help our clients. It seems like there's a product here. And so ultimately, kind of stars aligned where my friend Steven was looking to take this idea and build it as its own company, as a product. And I was kind of leaving a startup that I was at for maybe about a year and looking for something new. And so we joined forces to build what we were calling TVLabs.
Okay. I can see. I remember going to Google's offices years back. And this is right in the early boom of the smartphone thing. And they had walls of smartphones, like every model in a kind of library, and you could go and pick one off the shelf. Yes. I can't quite imagine that working with a 48-inch plasma television.
That's right.
Is that what we're talking about? Like just having to have access to every kind of television?
Pretty much, yeah. So if you're a big enough media company, you probably have the budget to have a warehouse somewhere that's just filled with televisions, a TV lab, where it's exactly for this purpose. You have a QA team, and before a release goes out, they're certifying the release internally by physically going to televisions, uploading a build, using the remote control to test the television and make sure that everything that was built and is working correctly, on my machine also works on the physical, LG TVs, Panasonics, Samsung, the Tizen platform. But not just that, we've got Apple TVs, we have Rokus, we've got,
of course, the Fire Sticks and all the
Fire Sticks.
Yeah.
There's
all the
so
stuff
much
that plugs in.
fragmentation, Chris.
Yeah, this instantly sounds worse than the multiple browser problem of the early 2000s.
That's right.
Okay, so before we get into what sounds like either a nightmare or a fantastic source of QA employment, just if we can step back, because I don't know much about development for televisions. I'd always kind of assumed they just wrapped a crummy browser, but give me a bit of an insight into the world of a television app developer. What are they working with?
So luckily, most of it is web technology, and most of it is wrapping Chromium and putting it into a television. The problem is, which crappy browser are they putting into the television is the question. And these things, I wish I had more of a depth of knowledge on, the specifics of every platform. What I can tell you is that most of these platforms are wrapping something like Chromium or SpiderMonkey. They're shipping, a set of their own SDKs onto the device. But then each device is going to have its own APIs for uploading builds, getting, different hardware controls on the television, permissions, access.
Oh, yeah. Because it's not just that, like, every television has a unique way of talking to it, and okay, sorry, carry on.
That's right. No, that's right. Every TV has its own unique way of talking to it. Some televisions run the Android stack, so there's Android TVs. There's also Google TVs. There's also the Chromecast. There's also a new platform that I believe is coming out. Might have already come out or is coming out early next year. I forgot. That's built on top of Android, which is the whole, Java stack and all of that fun stuff.
And Apple presumably is a flavor of iOS.
Oh, yes. They've got tvOS. Yeah. Then we've got the Tizen platform, which is built in Java. The apps, I think, are also web apps. I I'm blanking on that right now. But the thing I think you could take away here is that every single manufacturer, for the most part, unless we're dealing with the Android-based televisions, and that's a decent part of the market, all are a different fundamental platform for working and shipping on. And so you can imagine that there's frameworks out there that try to normalize, how standardize how you might interact with each television, but the devil is in the details. And so as you start to, build out features and, have maybe more complex interaction, or even just simple things like your use of Flexbox, it might, behave in surprising ways because it's this old version of SpiderMonkey running on this one particular 2017, Samsung Tizen platform, and that has 8% of your market share, and that's hurting your bottom line revenue. These problems actually matter, and so what's interesting, I think, for us is that it's not always necessarily the newer televisions that are the problem, because that's the first thing you think is, oh, you must be having to keep up with all these new televisions and new devices every day. No, the problems that we hear from our clients the most are, can you source this very specific 2017 Panasonic television for us that's based out of Asia or based out of South America, or this one feature only works in the UK, and we want to test that. Can you make sure that we have a UK television that's physically located somewhere in the UK? These are the types of problems.
Well.
Yes.
We're kind of getting ahead of ourselves, but do you end up scrolling through eBay looking for a particular model of television?
You can imagine there's a multitude of places where we might be procuring devices.
Okay.
Sometimes it's, if we're trying to get something really fast, it's friends and family. Hey, does anyone have this in their basement that we can borrow for a few days?
Yeah, Craigslist and that kind of thing.
That's right.
Okay. So let me see. One other question before we get into your solution is, how large is this market? Because I'm instantly thinking, okay, Apple have to have an app for every kind of television. Netflix have to. But how many players are there? There aren't that many television channels that have an app for every television, are there? How large is your potential customer base here?
It's pretty large when you consider it globally. So I think in the tech world in the US, we tend to be very US centric, but globally, everyone is consuming whether it's television via broadcast or television via streaming. There's many different ways to consume media on a television. The market is quite large, and there's some really big players: the Netflixes, the Amazons, the NBCs, the Warner Brothers of the world. Mm-hmm. There's medium players. In Europe, you have Channel, or the UK specifically, Channel 4 and ITV and all of those. But then there's South America, which has a very different market. So globally, we have this kind of massive market, and each one of them has different constraints and needs and hardware and all these different challenges.
And not all of them will have the budget of Apple or Netflix.
That's right.
That makes sense. Okay, so there I am, a medium-sized television IT executive who doesn't have the budget to have, or even perhaps the physical space to have a warehouse full of televisions to test on. Certainly doesn't want to hire QA engineers who are sitting there wandering around with a USB stick and a controller. You've been trying to automate this process. Take me through how you possibly automate this problem away.
Okay. Well, there's many layers to go through here. It might make sense actually to go bottom up rather than top down, if that's okay.
Okay. Yeah, sure. We can build up the stack.
So let's start at the very bottom, which is, I have a television, and this television, it has a screen. It's got HDMI inputs for plugging in different your PS5 or maybe your Fire TV, Apple TV, whatever it is. It doesn't have an HDMI out, right? So getting high quality video out of the television is not actually the easiest thing.
Yes. Yeah. Okay, we're right at the very first hurdle, and that sounds horrible. What do you do? Do you crack them open and try and solder in an HDMI output?
Well, I think you probably could. You probably could find a way to, do a hardware hack and, fiddle some wires. I'm imagining kind of like an action movie where, you're trying to defuse a bomb.
Tom Cruise could do it in a reasonable time frame.
We tried to hire Tom Cruise to hack our hardware, and it just it wasn't economically viable. Let's say that.
Fair enough.
Or maybe you got a little Flipper Zero here. I don't know. Anyways, the solution that we came up with is, well, twofold. One, there's certain devices where we do have HDMI out. And for that, an HDMI capture card, you can easily capture the stream in HD. You need to have a particular license. Not just anyone could be capturing HDMI out, because there's DRM on the devices that prevents you from capturing it in high quality. So you have to have a license to be able to do this. And so for devices like set-top boxes, I'm talking about the Fire TVs, Apple Sticks of the world. I feel like I'm repeating myself a lot. We're going to be hearing about set-top boxes for the next hour. HDMI capture cards are the way that we get the video out.
Okay.
But for televisions, it's a little bit of a bigger challenge, because televisions, we don't have that luxury. And so for that, we use cameras. Now, this poses its own, in and of itself, is its own challenge of how do you get the screen, which is a nice 1600 by 1280 rectangle. How do you get that and flatten it? Because a camera's lens is always going to be slightly curved, even for the flattest camera. So you're gonna have radial distortion around the camera, right?
Yeah.
You're also going to have all that really white light from the TV saturating all of the color and distorting the image. And so if you naively did what my co-founders did, before we formed TVLabs, you're pointing a webcam at a TV, and you've got this horrible, very saturated image that doesn't look very nice. It's not quite a rectangle around the TV, but kind of this weird distorted rectangle. And so what we did is we found, cameras that were going to be really good for the type of light and image that we're trying to capture. And our goal always was, you should be able to stream a 4K movie and for it to show up in your browser as if it was, you didn't know the difference. It was just shipping your television screen right into your browser. So we're taking cameras, we're pointing them at televisions. We're then taking that video stream, and we actually have 4 cameras on our boxes. So we're stitching them together. We're applying different undistortion techniques to flatten out the image, stitch it together into that rectangle.
Why 4 cameras? Is this a resolution issue?
It's not a resolution issue. We could do it with 1. And I think this is an early optimization that we made that maybe we would change now. But our goal was to always have a very tiny box that we could stack many, many, many of them next to each other and on top of each other, so that we can have a warehouse full of hundreds or thousands of televisions.
Okay.
And in order to do that, there's a certain point where space becomes, a limiting factor for how many you can have in your warehouse, unless you have a lot of vertical space. That's a challenge in and of itself. So what we wanted was to get the cameras nice and close to the television, so the depth of our boxes could be very narrow.
Oh, right. Yeah. So you've got to have a camera a certain distance away from the television to be able to see the whole thing, like a parent shouting at their child to sit back from the TV.
That's right.
You've got 4 up close. Yeah. Okay. So now I see why you've got a stitching 4 video streams back together problem.
Right. And then we need to make all these different, you have 4 video streams, but they're overlapping. They're going beyond the edges of the television stream. And so we apply different computer vision techniques to get that back to that nice rectangle. We apply an undistortion to flatten it. And color correct it. And then what ends up happening is that we have this video stream that we can then strip to your browser over WebRTC that's nice and flat, and you couldn't tell the difference that there were 4 cameras. There's no seam. It looks perfect.
Do you have the luxury of that being repeatable? Like, can you set those settings once for the 4 cameras and expect it to work with every television that you've got a box for thereafter? Or do you have to hand tweak each quartet?
So there is some amount of hand tweaking that we did early on. Now we actually have a pretty nice process for each one of our cameras. Goes through a tuning process before it even goes into a box, and then it's all calibrated nicely. And then when it's put into the box, it's great. But even with a calibrated camera, it's not going to be pointed, perfectly, head on to the television. There's always going to be a slight angle, and the TV might not be on the mount perfectly. So we have this calibration process where we click a button in our platform. It shows a special image that it uses to, calculate what's called homography with the television. Find that perfect calibration, and then it uses that math, the math that it derives from the calibration image, to find that perfect point of reference.
Yeah. So it's basically automating the test card of old.
That's right. That's right.
Okay. I'm already getting a sense that we're going to be solving so many micro problems along the journey to getting this whole thing working.
There's a lot of micro problems.
Yeah,
that is basically my life. Yes.
Okay.
So you asked a question that we're on a journey to get there, which is, how do you automate testing televisions? Yeah. But it's like building an apple pie from scratch. We first must invent the universe. We first must invent every single possible way to automate interacting with the television. Otherwise, it will consistently break in new and spectacular ways every day.
Yeah, I guess that's a competitive advantage as well, right? So in the long run,
that's right.
But yeah, it keeps your life interesting. Okay, so you've reached the point where you can stream WebRTC out of a television effectively.
But Chris, wouldn't you agree that it's pretty boring to stream a television that's not on? You'd probably want to be able to turn it on too.
Okay. Yeah.
So, we have the problem of input now, which is, we've got these cameras pointing at a television in a dark box. In order to do something useful with it, we're not even getting to the problem of uploading, your build to the television. And we'll get to there later.
Right.
How do I turn the thing on, and how do I navigate to a channel? How do I change the settings? How do I do all these things? Yeah. So we have an IR diode in there. We've got something called CEC, which allows you to interact over HDMI. For each individual platform, we've got web-based and gRPC-based protocols for sending messages back and forth to the television. You've got all of these different ways to interact with the television that we have to solve through hardware, and we have to solve through different types of APIs right on the box.
So I'm imagining you say the two main two ways you can send controls to the television are CEC, you called it. That's the one over HDMI, right?
That's right.
That, I would guess, is fairly standardized. Infrared, are you having to manually train the specific remote control? Is someone sitting there when they buy a new television going, okay, this is the up button, record that?
Well, I showed you my Flipper Zero for a reason, which is this is pretty useful for intercepting IR commands and reverse engineering how they work. Now, some of them are published, right? So every single television is going to have slightly different IR protocols for how you might send commands. So there's the basic stuff like turn on, channel down, channel up. There's more complicated things like I've held down the volume down button. That's now a long press. Each television manufacturer might have slightly different ways of implementing that IR.
Yeah, that didn't surprise me.
So we have a PCB, a printed circuit board, which has an IR, actually multiple IR diodes connected to it. And we'll send those IR signals over the IR diode, and that will communicate with the television, just how your very basic remote would. You said that CEC, that must be a very ubiquitous standard, and you can imagine CEC is like, again, set-top boxes. We're going to keep saying it. Fire TV. You turn on the Fire TV, that turns on your television. the way that works is that the Fire TV is sending a CEC standby command to the television saying, hey, turn on. The unfortunate thing is that while they are standard, quote unquote, they all behave slightly differently with each manufacturer, and not everything always works as expected. So we have many different things on our platform that's really tuned for the particular platform to work most reliably. And this actually goes with communication in general. We have to make sure that on any one platform, not only can we provide all the capabilities, IRCEC, whatever, but also be able to choose, in certain situations, you might want to test IR, but you also might want to test the Roku specific API, for example. So we have to provide all of them. And we'll usually choose the standard one for when you're trying to interact through our web platform, the most reliable for that.
Right. I feel like this is going to be a disappointing answer, but I have to ask the question. At any point, do we get a robot arm pushing the buttons on the television?
So our first prototype was a severed hand that would poke around at the television.
Like Thing from the Addams Family. That's
right. Again, just like Tom Cruise, we didn't think that was going to scale, so we had to decommission that particular path.
I was hoping that in just a few cases you'd have something like. Okay, so that makes me think of one other big input that you haven't mentioned to the television, which is power. Do you have some kind of power control so you can hard reboot the television when it crashes?
We do not. We have, I think, 5 different power controls for
5. Okay, run me through those.
So, okay.
Why is one not good enough?
Man, so okay, I come from a background of Erlang and Elixir and the Beam, and the philosophy is let it crash. The problem is that when you're managing hardware, things don't always crash in a clean way. They crash in dirty and weird ways, and they'll manifest in just things will crash loop and generate 1.5 terabytes of logs, or your cameras will just die and stop working. And so there's all these different little mechanisms that we have that are monitoring the state of our system and trying to detect these degradation in quality. And depending on what fails, we might want to power cycle the device at a different level. So the first level is the device itself. So you can, through the remote, turn it on and turn it off.
Yeah.
The thing that you might know owning a television is that turning it on and off might not actually turn it off. It might turn the screen off, but it might just go into a standby and then it's just ready to go back on.
Yeah.
And so that standby is not always, useful enough when you have like some weird state that you're in and you want to power cycle. So the next level on the hardware is power cycle the actual power going directly to the television itself. And for that, we have a power relay in our boxes that is able to turn the device on and off. Kind of sibling to that is our software that is running next to these devices. Sometimes that goes wonky. And so we have Docker containers running. We might recycle those Docker containers. So that's another way of turning it off and on. The compute that's on the device itself, we might need to turn that on and off. And then if all else fails, we have a relay going to the actual wall and we'll turn off the entire power going to the entire box off, wait a few seconds and back on again.
So you've mentioned there, we haven't really looked at it. There is some kind of computer inside this box so the cameras aren't trailing a wire out to some central server. There's local processing inside the container.
That's right. So every single one of our devices has basically a beefy GPU driven computer that's sitting on the device itself that's running our specialized software and bundling up a bunch of vendor-specific software that allows us to communicate with the television, they're all connecting up to our web platform, which is, saying, hey, someone wants to use an LG and you've been selected because you're available. Start this session and initiate this WebRTC connection with this particular user. So all of that is running, Elixir on our devices, but we're doing a lot more than just taking frames off of cameras and audio and shipping it. We're also doing machine learning on every frame. We're also doing computer vision and audio processing and recording the video and shipping it out to the cloud so that you can watch your sessions after you've interacted with it. So all of that is happening on this specialized piece of hardware that's connected to our printed circuit boards that has all these different peripherals that we can control through our software. We also have, our own power relay. We have a display on the device that's driven by little C++ program we have that can tell you the temperature of inside of the box and can send an alert up to our web platform if it's crossing a certain threshold. There's all these little things that we need to be monitoring at all points in time to make sure that our boxes are healthy and safe and all that fun stuff.
Do you also have, this is a slight aside, but do you also have cooling, and how does that interfere with capturing the audio?
That's a very good question. We do have cooling. We have kind of the ambient cooling of the room. We have, air conditioning that's pumping in. But we also have on either side of the box, we've got 2 fans that are blowing air in and out of the box to provide circulation. So they're not blowing air in, they're blowing air through the box.
Makes sense.
Which provides enough cooling to keep the boxes at the right temperature.
So,
and you asked about audio.
Yeah.
You asked about audio. So, audio is the noise of the fans isn't necessarily a problem because we don't have a microphone in there. We don't have HDMI out, but we do have audio out. So we are able to capture.
Do you always? Because I would have thought for a lot of televisions you do, and for some you don't.
For every device that we're working with, I believe we do have the audio out.
Okay, that's easy. Okay.
Yeah, I guess I would have noticed if we didn't, because you'd hear quite a bit of noisy chatter of whatever else any one of our clients is testing at any point in time.
Yeah, actually, that raises the thought that if you walk into that room at any point, it must be a cacophony of different television channels.
Yes,
yeah, okay.
It is, but it's, you wouldn't see them because they're contained in these boxes. There's the vent where the fan is, you can actually see a little bit into the box, but for the most part, it's very much enclosed, and you'd be none the wiser. And it's actually pretty quiet. We do have 2 fans, but they're not making a ton of noise. It's a surprisingly quiet operation.
Okay, so we've got a whole these boxes. That was one thing I wanted to pick you up on. You're controlling this. Your central controlling software is Erlang, right? You're running the Beam on the box.
That's right.
Why Docker as well? They seem to be slightly overlapping in what they do.
They do. So we've tried many, many, many different approaches here. So this can go into a whole side conversation. And I do need to remember that you asked me about how we automate working with these televisions. So we have to work our way back to up.
Yeah, we're getting there. We've got a long journey.
When we first started out, we were basically just shipping code directly onto our compute and, running it on there natively, which is very easy in a lot of ways. The problem that we ran into, we're building on top of NVIDIA hardware, and the NVIDIA hardware poses a lot of challenges, especially when you're working with native libraries. So we're working with OpenCV. We're working with a technology called GStreamer for our multimedia pipeline. We're working with what's some other native stuff we're doing? I mean, kind of the machine learning stacks and a bunch of NVIDIA specific GPU stuff. camera drivers, all of this. It becomes very difficult to be able to ship your software to all these different places and have it run reliably, and to make version upgrades and changes doing it natively on the box. I'm not saying it can't be done, but what we found is that Docker just became a lot simpler for us to be able to deploy new software. We have a build box that's running on an NVIDIA Jetson somewhere in our office. It's hooked up as a GitHub Actions CI runner, and we're able to build an image, push it to our local Docker registry. All of our devices, when they're done with the session, pull it down, power cycle themselves, and it just becomes a very simple way of deploying our software. The other challenge that we have is that we're running a bunch of third-party software. Not all of it is designed to be run on ARM. So we have the problem of, how do you emulate certain software? So we've got QEMU. I don't know how you say that correctly, but we have.
No, I've always wondered. QEMU, that one, right?
The Q emulator.
QEMU, yeah.
So
however,
we have
someone will tell us in the comments how to pronounce it correctly.
I hope so, because I've been wondering for some time now. So we have the problem of, like, how do you run this esoteric version of Java 7 or 8 that's way too old and has all these issues? How do you make that safe and run it on the box? If any of these fail, we do have things that segfault. Need to restart them. So. Yeah. Docker is kind of like maybe bloated and way more than necessary, but it does give us these really nice way of releasing and packaging up our software and allowing us to really rapidly release new versions to our software without having to think too much about the orchestration.
Right. So are you then not using the kind of hot deployment features of the Erlang Beam? Are you just doing it all through Docker? Okay.
We're not. We're not really keeping, at least in our edge compute, let's call it, we're not really keeping so much state that needs to be maintained between one session to the next. A lot of that is managed by our web platform that, keeps queues of, user A wants, this particular device, and, user B wants, something slightly different. But there's one device that matches both of their criteria. Who gets it first? That kind of state is kind of distributed in our web platform, and a whole different set of challenges. And that maybe would be useful to use the hot code reloading features of the Beam, but we don't actually use that anywhere. We try and have other different techniques to make sure that that's reliable and works well. Okay,
in that case, it is time to zoom out of the box. You've now built a box in which you can shove a television, you can tell it things, and you can see what it's showing back. And that box is now on the network. What do I do next to build out this service?
Well, the first thing I think before you automate televisions is that to know what you're automating, it's often very helpful to be able to run through it yourself. So imagine I'm sitting here with my remote control. Look at this. I have one right here. So I turn it on. I go to the page I want to navigate.
Yeah.
I go to the thing. And while I'm doing so in our platform, I'm taking screenshots of this. So we call this our access platform. And how this works is our system, you say, give me any LG, and it will pair you with the first available LG. It doesn't care, what year it is or whatever constraints. You can make a very broad request. Just say, give me the first thing that's available.
Okay.
I can go and test on it, take those screenshots. And now I have a good sense of the path for which I want to test. Then I go into our automation product. This is a very visual tool for interacting with the system. And we allow you to basically take those screenshots that you just took in your access session and mark them up. So imagine that you wanted to go to, let's make up an example here. There's some apps where you might have like a channel guide. I'm thinking of one very particular app developer, but I don't want to use their name. So imagine you have like a channel guide where there's all these different shows that you could watch on their app. And so you want to navigate over to that. You want to pick a particular show. You want to watch it. You then want to pause it and test that when you scrub back and forward, that it actually moves you back through content. And then when you hit play, it serves you an ad.
That seems like a very reasonable thing to want to test. Yes.
So the way that this works on our platform, because we're trying to target across all these different devices, using something like, HTML, hooking into your code, or using, the structure of HTML to test semantic things in the DOM, it just doesn't work well for this type of testing. And so we've taken this very visual-based approach where you kind of tell the system, you give it visual cues for, if this logo, if it appears on this place on the page, and there's this text that says, home in this particular part of the screen, and this thing is dominantly, this particular color of yellow over here, I have a pretty good idea that I'm on the home page. So
right, so
you'll draw some
figuring out where you are.
Right. So our system can then take that and it will be able to process every frame and then look in those rectangles that you drew and say, what am I seeing here? Am I seeing, this particular piece of text? So I'll be running, different types of machine learning to pull this information out, pulling bounding boxes and, using OCR to grab text. From that, you can build a workflow. So we have a drag and drop tool, and you'll do something like open this app, wait for the home page to load. Check, am I logged in or am I logged out based on the presence of, the login modal?
Yeah.
If I'm logged out, go through this workflow. If I'm logged out, go for this other workflow. Okay, now I'm logged in. Now I need to go to that channel page that we talked about. So issue these set of commands. Use generative AI to navigate around the screen because now maybe there's some complex menu that I need to navigate and the content changes dynamically. So we'll grab a frame, we'll generate the sequence of up, down, left, rights, and enters to get to where you need to go. Then we'll use our vision-based system to video starts playing, we're grabbing frames, and our system can kind of understand the content that's playing and be able to draw some certain types of information from it. And then, we can detect the ad based on maybe some content or the presence of, some text on the screen, or maybe we know the ad, or we can fake it by, intercepting the network. And so you can do assertions in our platform based on that. So this whole visual system is kind of how we can pose these tests together.
Right.
Pause there for a second.
Right. Yeah. So, so I do this markup stage first before I manually against one known television, and then I can script out the whole thing, which you will then compile down and send to the individual container.
So you found me because of Lua on the beam, and this is where this enters the picture.
Right. Okay.
So I'm trying to describe this to you without a visual aid, but we have this drag and drop workflow builder.
Right.
And as I said, open app, wait for the screen, enter these series of commands, maybe use the keyboard to enter some text to search for a particular piece of content. You could do it all through this visual tool that's designed for QA, who are maybe not necessarily developers. That workflow that you see visually compiles into Lua code. This Lua code is using our DSL that we've built, and that gets shipped down to our physical device. That physical device implements that DSL, which is using computer vision and machine learning behind the hood, but also interacting with our hardware APIs and maybe some of these vendor-specific APIs to actually run through the test, run through that workflow, make certain assertions, run loops, do whatever it needs to do, and then emit events back up to our web platform that then get visualized for you. And you have this like really interesting visual way of seeing not just the recorded video of your test being run, but the state of the system as it's running through that. So the system will be like, okay, right now I know that we're on the homepage based on what you've told me about the homepage. This is the network activity while this is happening. This is the audio level while this is happening. These are the elements on the screen that you've told me about. I recognize the presence of this thing. This thing is not here. And from this, you could build this really powerful way of navigating and making assertions about content and then reporting it and being able to see changes between different runs.
Okay, so if I then go to test this against a dozen different kinds of television, am I going to be able to step through and say, okay, they all made it to the login page, they all made it to the channel guide page, but one of them didn't make it past the channel guide page and got stuck, and that's the one I need to do more testing on?
So when you write a test on our platform, you can then schedule it and say, I want this to run on these 5 different devices. And because it's visual, and because most of the time the look and feel of these apps is pretty consistent across devices, this becomes pretty powerful for writing these end-to-end tests that are implemented in completely different technologies. And so what you're pointing out is that you can find inconsistencies in implementation or bugs or maybe slowness or buffering or just some issue that you weren't expecting on one particular device. And so you might run this test. You might run it against, I make a code change in my app. I'm going to sideload a build through the TVLab's platform on my CI. It then runs on these devices and it reports back to you. It worked great on Panasonic. It worked great on Sony. It worked great on Samsung. But on Fire TV, you had this issue. And then you can go in, see the recording, see what the system was doing as it was navigating through your test. And then you have all this information, including, the device logs and kind of all the telemetry that we're collecting, also network calls and things like that you can go and inspect and figure out what went wrong and maybe go into your logs and correlate some sort of issue.
Yeah, because remembering the bad old days of the browser wars, my expectation would be that it fails on something most of the time for some dumb reason. Mm-hmm. Right, Okay, so I've never really been happy with this kind of front-end testing because it's always fiddly and messy, but that doesn't sound... If it doesn't sound ideal, it at least sounds like we're approaching the best that can be done. Is that fair to say?
I think so. I think the ideal experience is that you have something akin to, open telemetry running inside of your actual app, and you have all the traces and, everything that you might need to be able to debug the issue. And you might actually have that. And you might have that in production. You'll have, your analytics systems that can do measurements. But we're talking about many different stages in the software development lifecycle. And you also have to think of the volume of changes and the audience and the fragmentation of where all these apps are going. They might be going on, I actually don't even know the count, but it could be hundreds or I don't think thousands, but maybe hundreds of different target platforms with slightly different versions and things like this. We have the same problem in browsers, but the technology is more consistent. So solving these problems is very challenging. And the point that we're trying to come in is that we can help you in any different part of the software development lifecycle. And we're trying to provide you tools that provide all this different telemetry where when things are flaky, which they will be, we can give you more indication for why they're flaky. Was it because the network was being finicky and we couldn't load the content from this particular CDN pop? Or maybe it's because on this one particular platform, you actually do have a legitimate bug that you need to fix. we're trying to help you isolate those and to be able to run it on these different platforms so that you can find these inconsistencies and be able to fix them without having to manage this massive fleet of hardware and have an operations team to manage it. We try to do that, solve all those problems for you.
Yeah. I see that as the business pitch. Yeah, and it makes sense, right? Because that would be hard to do in-house unless you're one of the huge players. In which case, you're probably going to end up trying to solve the same problems that you're solving, or just throw bodies at it. Yeah.
And even if you have, the budget to throw a lot of money at it, these are really challenging technology problems. And it's not just like there's one big problem. It's like many, many, many different small to medium and large size problems.
Yeah. Let me ask you about one specific one, because it's like a devil's in the detail type thing that comes up in these. Sure. I have found as a user of like TV apps that sometimes you're trying to navigate around a 2D space that wants a mouse, but you've only got up, down, left, and right on the remote control. So getting the cursor from where it currently is highlighting to the thing you actually would like to click on is sometimes really counterintuitive, right? Sometimes you click left and the highlighted button jumps to a place you didn't expect. Right? How on earth does machine learning get around the potential craziness of navigation you get in televisions?
Well, we have the luxury of being able to view many, 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 many different sessions of interactions with televisions.
Okay.
And I'm not trying to claim that we've solved this problem. I think this is kind of one of our biggest challenges that we have to overcome, which is, can we really, build an agent that can truly understand what you're seeing on a TV, understand what is navigatable and what's not, what's clickable and what's not, and be able to infer any different one of these things. There's a feedback loop there, which is if I press left, what changes on the screen? Am I able to recognize what is actually, currently highlighted on the screen? To some extent, we're able to do that. To other extent, it's really specific to the app and the platform you're on. This might be, as you said, I'm imagining these like kind of like sidebar navigation things where these things like pop into existence that you didn't expect and, jump over.
Yeah.
Or sometimes you hit left and it just stays exactly in the same place. And it's only when you hit the back button does it jump you back to the menu.
Yeah, crazy navigation in TV apps. Definitely a thing.
Yes.
Yeah.
So I think this problem is solved over time by being able to train on an agent that is able to be anchored at any one point in the screen, make a change, observe what changes on the screen, and then if it has the ability to infer what are the pieces of content that are navigatable, clickable, you can sort of build like a graph of understanding of this is how I move across the app. And if you can do this with enough time and enough examples, you can actually build a whole map of how to get from point A to point B through enough of these iterations. So I think that's kind of the goal, is if we can automate that, then we have a really powerful system that could actually probably crawl your TV app and find your issues for you. But we're not quite there yet today.
I can see how you've got the training data, if not yet the solution.
That's right.
Okay, so I think we should then get into scheduling, because this is clearly a problem. How many different kinds of TV do you actually have in the warehouse? What kind of numbers are we talking about?
I don't want to reveal too many numbers. I would say
give me a power of 10.
We'll be in the hundreds.
Hundreds, okay.
The challenge that we have is it's not just about like different types of device, because for any given manufacturer, they probably have a low-end television, medium, and high-end device at all different price points. They also have them at all different sizes and then different capabilities. Maybe some are built for something called like, oh man, I'm blanking on this. There's a new standard for streaming that is kind of going to disrupt app stores. And there's something called 3.0, ATSC 3.0, which is a combination of broadcast and internet protocol coming together. So you might have certain devices that have these capabilities that I think are called next gen televisions. You'll probably be hearing about this in the next few years.
Right.
We need to have kind of all of those. But what's actually really key is we don't have to have all the different sizes. That tends to not matter so much. What matters is the low end versus the high end are going to have very different capabilities and have different performance capabilities. But the 42-inch versus the 65-inch probably going to be about the same. And so we've optimized our fleet to be able to carry 55-inch televisions because most manufacturers have that size. It's a pretty popular size. Now, I mentioned much earlier that the problem that we tend to hear from our clients is not, do you have this latest and greatest device? It's, do you have this like device from 7 years ago that's, 8% of my audience is still on that we're having this one bug on that's breaking all streaming. Maybe a very old boxer is fighting some YouTuber and we have to solve that problem.
Yeah, because I imagine like most people only change their television once a decade, so you've got to support the old stuff.
That's right. So we have, I think, going back it's like 6 or 7 model years for most devices. And, our inventory tends to be smaller around the older stuff and, more volume around the newer types of devices. But then we have these shelves of set-top boxes that we keep talking about where those are really easy because they're small and, in a small volume, you can have a lot of them. But it's the televisions that pose our biggest challenge.
Okay, so I'm imagining that you've gone through this warehouse of hundreds of set-top boxes and televisions, and you've tagged them with metadata like, I'm an LG device, I'm 55 inches wide, I come from this year, and I'm running this operating system, right?
That's right.
And then I, as an app developer, say, I want to test on one of each of the major brands. Now you have a classic scheduling and queuing problem. Right, you've got to ship that test to the available TVs that match those criteria. Tell me about that.
Sure. So we called our demand system, and it's a very boring name, but it takes demand for particular devices and it matches a user based on a priority queue of do I have a license? So we charge for our product based on concurrent access to televisions. So depending on the number of licenses that you have, we will allow you to connect to that many televisions at once. So if you have 3 licenses, then you can run a test, and at the same time, we could run it on 3 different devices. But you are also competing with your teammates who, might not like that. Yeah. So we will, each one of our clients sits on a different queue. And so if you queue up, 100 different tests, we will try to run all of those 100 tests for you. There is a max time for how long we'll let something sit in the queue. But you can schedule up all this different demand, and we will serve it to you based on the number of concurrent licenses. But we will prioritize those requests globally across all the different organizations who might be using our devices in sort of a round robin fashion. So what this does is that it minimizes the amount of contention between different organizations who might be competing for the same devices. And we'll prioritize based on time. But if you haven't had a request recently and someone is putting in a lot of volume, that will over time start to decay a little bit and get prioritized a little bit lower than the person who's just like, hey, I'm here to test today, and I'm not sending so much volume through our system. So this is using
optimizing for throughput there.
That's right.
Individual, yeah. Okay.
That's right. So we want our system to be utilized, and we want it to be as high. We want to be able to use our capacity to its full extent as much as possible. And so to order to do this, we keep, I I guess you can kind of think of it as like a distributed database, but we keep an in-memory database that uses CRDTs to track the current state of each device in our fleet.
Okay, that's interesting. I wouldn't have thought CRDTs come into this. Tell me more.
Okay, so our web platform needs to be able to serve many different geographic regions because we have customers who are in the US. We also have customers who are in Europe and the UK. We have customers who are working in Asia and places like India, Tokyo, things like that. So our web platform, is running different edge compute all over the place to be able to have a nice experience for those customers because it's a very interactive platform that we offer. The problem here is that each individual device can only be used, by a single user at a time.
Yeah.
So in that sense, each of one of our devices is its own source of truth for am I available or am I not? However, sending a request to every single device and being like, hey, are you available to take on a new session is not very efficient. And also those devices I mentioned, they connect up to our web platform. They might not be connected to the same node that you're currently interacting with. I'm connecting to our web platform. I'm using Phoenix Live View to interact with the web platform. I'm sitting in London, whereas we have a server sitting in New Jersey. So our device actually might be connected up to that device in New Jersey. Now, some other user in San Francisco might have just used that and now it becomes available. How do you know about it? This is where the CRDT comes into play. So the CRDT is keeping track of the current state of each television. Is it available? Is it online? Is it in use? Is it healthy? Is it available for connection? And we basically use that. Our demand system is querying that thing as kind of like the first check for, can I serve this user request right now, or do I need to keep them waiting? And we'll let them know that there's nothing available and that we expect something to come online soon, or that their teammate is currently using it. And all this information is tracked by the CRDT.
Right.
But when it comes time to, okay, we now think that this device is available, we've selected you to pair with it, we'll then initiate a session. And the way that this works is that even if you're sitting in London, but the device is in New Jersey, through our pub subsystem, it will send the request for the session down to that device. And now, because that device is a source of truth, it will either accept it, and by sending a message back and saying, let's initiate a WebRTC connection, or it will reject it and say, hey, I'm actually unhealthy, or, it reported my session as available and I'm actually unavailable due to some bug.
Right.
But that ends up being the source of truth. The CRDT is the thing that keeps it fast and is kind of like this in-memory database for knowing who's available and online.
Okay, so it's kind of like you're connecting to a central server to find out which peer-to-peer connections you're allowed to make.
That's right.
Sort of. Yeah.
Sort of.
Yeah, and the demand server is connecting to the local database, which replicates the actual source of truth, which is the individual container.
That's right.
I think I have that in my head. Okay.
That's right. And when we say server, we're talking about, we just have our Elixir apps running in the cloud. There's not like all these different microservices that are responsible for one thing. It's just one web platform that has all these different responsibilities managed by gen servers that use things like hash rings to distribute the load across all of the different servers globally.
Right. I was going to say, does this actually end up just being a bunch of Erlang actors? And is that That's the right. reason for choosing Erlang?
Well, there's many different reasons for choosing Erlang.
Tell me.
So, okay, there's a lot of problems that we're trying to solve that I think Erlang and Elixir and the Beam VM, the Beam virtual machine are very good at. So the Beam virtual machine is really good at fault tolerance. Let it crash. We'll restart it for you if it goes down.
Yeah.
It's good at low latency and decently high throughput systems. And it's really good with building systems that are relatively simple due to immutable data and functional programming. And then there's the whole distribution aspect, which is being able to connect nodes that are globally distributed and have them communicate to each other and send messages back and forth and subscribe to different topics of interest and not really have to worry about the orchestration of that all.
Yeah.
And what's really
it's
good,
normal bread and butter programming in Erlang, right? It's not a weird thing. Yeah.
That's right. And so what's so interesting, I think, about Elixir for this particular solution is in any other programming language, you'll probably have to have a constellation of other services that are just for doing the communication. Like if we take WebSockets, for an example, all of our different devices, TVs and set-top boxes, the way that they communicate up to our web platform is that they make a WebSocket connection. For most other systems, you'll have to have a separate service just for holding on to those WebSocket connections and then using something like RabbitMQ or something else to do, eventing to all your other systems. We could just do that in Elixir and Erlang, and that's really easy. But the thing that enables is so interesting is you can now do distributed pub sub, where I can click a button in the UI that emits an event. And that is just pub subbed directly down to the device that's listening to a particular topic. And it acts as this like giant distributed system that's heterogeneous, that's actually running very different code, but it can, communicate with all the other nodes in the system with very little effort. And there's this term that I think that's been going around in the Beam community that I really like, and that I think comes to the core of why I like it so much, which is operational simplicity. In order to do this, it takes very little effort. It takes very little effort to build these kind of tools, and to network it together is just through DNS. To do the WebSocket connection is like these standard tools through the Phoenix framework that are just very available and easy to use, and would require quite a lot of specialized knowledge and operational complexity in order to deliver in most other platforms.
Yeah.
Now, that's not to say that we don't use a lot of other technologies. We've got Rust, we've got Go, we've got C++, we have Lua, we have JavaScript. But Elixir sits at the core and kind of solves these fundamental data distribution and communication problems for us.
Yeah. I can see if I were just taking this on paper, I would, by the time you've got to obvious complex failure modes, interesting networking protocols, WebSockets, WebRTC, lots of scheduling stuff and queuing. I'd be surprised if at least Erlang in one of its flavors wasn't on the short list of technologies you use. Mm-hmm. Can I ask why Elixir rather than pure Erlang or maybe Gleam?
Well, the reason I left Bloomberg back in 2016 was that a manager of mine, I was kind of interested in Elm at the time. I had done a little bit of a stint of Haskell in my programming languages class in college. And when I joined Bloomberg, I was doing quite a bit of C++ and Fortran, and that's a whole other conversation. I then dipped my toes into JavaScript, and I mentioned that whole single page app framework. But I was kind of like itching for something else, and I got into this functional programming kick with Elm, and I'm like, this is so cool. My manager was like, oh, you like Elm? You'd probably really like this this thing that this guy in the Ruby community has been talking about called Elixir. And so I was like, oh, let me try that. And what I found with Elixir was this idea of pattern matching, which is something I'd never seen in any other programming language. And that was the thing that got me hooked. And so I left Bloomberg to go do a media startup called The Outline back in 2016. And I basically have never looked back, because once I found Elixir, I just found the way of solving problems just so approachable, and it just made things that I thought were really hard in the other languages I've used before really elegant and simple. And I was able to approach really interesting problems. I was at a sports betting company for 4 years, and we were doing a lot of real-time data processing. And we built almost the entire platform in Elixir. It's just something that I think I don't want to say it's part of my identity, but I have built, a lot of knowledge and expertise in it. And I find that, I'm able to do a lot with very little relative resources with the Beam. And Elixir has just been my tool of choice. Now, I know you've had Louis Pilfold on the podcast. Him and I we sat down for dinner at Code Beam EU last month in Berlin. He's been working on Gleam for the last 4 or 5 years now. I'm not sure. And I've been sponsoring him since close to the very beginning, because I think it's just so great. The Beam is this amazing piece of technology that's, in my opinion, very underutilized. And it's great to have more players and more ways to onboard people into the ecosystem. So, if there's something better that comes out than Elixir, I would certainly try it. I've got my rewrite it in Rust poster right here. I love technology, and I love trying new things, but Elixir is just kind of this hammer that I find it's useful in so many different contexts, and is so capable, and allows me to with just very few people build a product like TVLabs with relative ease and kind of like a straightforward path. That's why I'm really excited about it.
I can see both the natural fit with the domain, given the amount of networking and queuing and reliability, and even the people I know who have the broadest tastes and palettes for programming languages. They usually have a favorite one too, which is just the place you go to get stuff done, right?
It's home.
Yeah. I think mine at the moment is PureScript, but I'm always tempted away slightly. I love PureScript. And it's my language I choose when I don't want to think about which language to use.
Wow. I haven't heard of PureScript being used in quite some time. The one that does keep popping up is it ReasonML?
Yeah.
Is that the one that's very front end focused and is kind of like has a really tight integration with the React?
It's now we did a whole episode on this, and I wasn't expecting a test, but yeah, it's like if you want to take OCaml to the browser, that's where you go.
I think it is Rescript. I don't know. They might be related. My OCaml is. I need to dabble in OCaml. There's some cool things happening in that community over there.
Me too. Yeah, I need to spend more time with OCaml. There are only so many hours in the day. That leads me to ask, perhaps to wrap up, hours in the day. Where are you spending yours in the coming months? What's left to solve in this space?
So we've been in business now for about 1.5 years, and we've been working with customers and clients, but we're very much in our go-to-market phase. And so a lot of this is taking these fundamental products and features and making them very usable, really dialing in the UX. I think we've spent most of our time making the system reliable. And the 5 different ways of restarting our system goes into it, where we've had to dog food our platform and use it over and over and over again and run into all these stumbling blocks. And it's only until recently where we feel that our platform is so reliable that it's really useful for other people too. And so what we're spending most of our time on is in JavaScript land and Svelte, and is in polishing these tools and building these features for introspecting state and really being able to visualize what's happening in our system so that it's really easy to go and diagnose a problem. And this is kind of like the very top layer of our system, where all of that low level stuff underneath it is kind of abstracted away from you. And our product just seems like, so boring and, obvious that you'd be able to work with a television, but there's just all these little bits and pieces and hard problems that we've solved along the way that make the high level thing really work. So my time and my focus is, spending a lot of time leading the team to kind of solve these UX problems and make the product usable in a way to analyze your problems and find correlations and kind of build, like the observability tooling part of our product that makes a reported error in CI easy to dive into, find the root cause, and jump back out of our product.
Yeah. As hard as stitching together 4 live video streams in a reliable, scheduled, queued, distributed network of television sound, it's probably still not the hard part. The hard part is making things usable for users.
That's right.
That's always the hard part.
It's always JavaScript that's the hardest part.
I'm not saying a word that you said it. You're now on record.
Oh, no.
Yeah. On that note, maybe I should leave you to go back to presumably Figma and keep working on the UX.
That's right.
Dave, thanks very much. That is fascinating. And one day I'd like to go and visit the warehouse where all the televisions are kept.
We'd love to have you.
Awesome. Thanks. Thank you, Dave. As always, you'll find links to the things we discussed in the show notes. And if you've enjoyed this episode, please take a moment to like it, share it with a friend or a social network, and make sure you're subscribed, because we'll be back next week with another... No, we won't, actually. We won't be back next week with another episode because I'll be taking a break for Christmas. So happy Christmas if you celebrate it, and, just general happiness from me if you don't. Thank you very much for your support during this year, especially if you're one of the people that supports us on Patreon or YouTube memberships and helps keep Developer Voices running. Thank you. Before we go, I'm going to leave you with a question. Dave mentioned the Apples and Netflixes of this world, and it got me wondering. You hear people in this industry debating what the plural of database index is. So I ask you, is the plural of Netflix Netflixes or Netflices? I shall be spending far too much time thinking about that over the holidays. So on that note, I've been your host, Chris Jenkins. This has been Developer Voices with Dave Lucia. Thanks for listening.